Hey there. Last section of the chapter, section 3.9, antiderivatives. Section's really easy. It's just doing derivatives backwards. We do that in math all the time, right? We learn to add, then we learn to subtract, we learn to multiply, we learn to factor, we learn to do squaring numbers, then we learn to do square roots. So this is nothing different. Got a simple function here, x cubed minus 3x plus 2. Suppose that was the derivative of a different equation. What would that equation have been? Well, when we take the derivative of x to a power, remember we multiply by the power and then decrease the power by 1. So we want to undo that. We're going to increase the power by 1 and then divide by the new power. So it would be x cubed divided by 3. Here we have 3x to the 1 power. We're going to increase the power by 1. So that's going to give us x squared. And we're going to divide by the new power. So we'll keep our 3 and divide by 2. Here we've just got a constant. We know the derivative of any x term is a constant term. So the antiderivative of a constant is just going to be that constant times x. And we're done, right? You guys are about as conversational as you are in person. You know we're not done. You know that there's a 0 here, and that 0 is what you get when you do the derivative of a constant. So we don't know if this original function, quote unquote, had a 0 or had a constant, but it might have. So we're just going to put a plus c there to make sure that we understand that there could have been a constant there. And in the next video, we're going to look at situations where we do actually care about that c. And I apologize, I should have put primes on all of these. These are the derivatives we're looking for the original function. Just like when we did derivatives, when we've got something more complicated like a quantity to a power or an expression to a power, we want to simplify that before we try to do the antiderivative. So here we would multiply this out. We get x squared minus 10x plus 25. And then we would do the antiderivative of that. Antiderivative of x squared, increase the power by 1, divide by the new power. Increase the power by 1, we get x squared, divide by the new power, 10 divided by 2 would be 5. Constant, the antiderivative is going to be the constant times x. And then, because there might have been a constant on that original function, we put a plus c to make sure we know that. Pretty simple stuff. Same rule also goes for these as when you were doing derivatives, is if it's not real easy, you're not just applying that simple rule, increase the exponent, divide by the new exponent, you're doing it wrong. You probably need to simplify somewhere. How about this one? It's another one of those I remember catching me when I was your age. Not your age, Michael. That was only a few years ago for me. X squared is a constant. This is a trick question. I would never put it on a test unless I warned you ahead of time it would be there. But this would just be pi squared x plus c. We're going to have to deal with trig, but the good news is the only trig we're going to have to deal with is trig that you already know is the derivative of something. Like, you know the cosine is the derivative of sine, so you know that's just going to be 3 sine t. The thing you're going to run into when we're dealing with trig is you got to remember the derivative of cosine is negative sine. So the antiderivative of negative 4 sine would be positive 4 cosine of t. But again, there's not going to be any tricky questions there either. The antiderivative of secant squared will be tangent. The antiderivative of secant tangent will be secant. And we'll look at the tricky stuff at the end of chapter 4. Like I said, here, you got to simplify before you start, because we can't just do the antiderivative of a big ugly fraction like that. We'd want to rewrite it as 5 over x to the 6th minus 4 over x to the 3rd plus 2. This is x to the negative 6th power, so we would increase just not f, that's g of x. Increase the power, right? So it would be x to the negative fifth. And then we would divide by negative 5, which would give us negative 1. Should work that out. Hold on. It's helpful to look at these as it was when we were doing derivatives. If you rewrite it as 5x to the negative 6th minus 4x to the negative 3 plus 2, then it's easier to apply the rules until you get used to dealing with the x's in the denominator. So add 1 to negative 6, we get negative 5. Divide by the negative 5, that'll give us a negative 1. Here, add 1 to the negative 3, we get x to the negative 2. Divide by negative 2, give us a positive 2. This is just going to be plus 2x, and of course, plus c. So we would get negative 1 over x to the fifth plus 2 over x squared plus 2x plus c. Remember the tendency when we were doing the derivative that the denominator should increase in power each time? Same thing is true here, but backwards. If we have a 6th power in the bottom, it should become 5th. If we have a 3rd, it should become 2nd. All right, that should get you through number 20 in the homework. Next video will get you through the rest of the section. Talk to you soon.